Our next speaker is Viktor Farcic. He's the open source program manager and developer advocate at Shipa, a member of the Google Developer Experts and Docker Captains groups, published author. But you know what? I'm actually a subscriber to his YouTube channel. He has two YouTube channels, DevOps Toolkit and the DevOps Paradox. They're really cool. I actually get a lot of updates from him through his videos. I don't know if he knows this, but I am a follower. So let's talk about shipping that code that we just tested. And if you're talking about shipping code, Kubernetes is probably a word that you heard. And if you haven't, you probably are lucky, or maybe not. So let's hear from Viktor why developers do not need Kubernetes. Viktor?
Thank you so much. Yeah, so you already heard, my name is Viktor, and let's talk about why developers do not need Kubernetes. Actually, let me fast forward immediately. Developers do need Kubernetes. It's more that developers shouldn't need to know that it exists, which is slight variation on the initial title. So let's go slightly back in history, right? Like 10 years ago or something like that, we got Docker, we got containers. Everybody jumped into containers. Everybody started using it almost immediately because it was very user-friendly. Anybody, literally anybody, could become a master of how to run containers with Docker in almost no time. Now, over time, we got Docker Swarm, which was a container orchestrator, which is orchestration of containers is probably an absolute necessity if you're going to do anything serious with containers. And Docker Swarm was extremely easy. Again, anybody could run containers in production in no time. But that simplicity came at a cost, and that cost is that it wasn't flexible enough. It didn't really offer the features that we needed. And eventually, we all switched to Kubernetes, because Kubernetes gives us everything we could hope to have and everything we need to run successfully containers in production. But the problem is that Kubernetes is extremely complex. And it is not complex because somebody did a bad job, but because there is a real serious necessity for that complexity and that extensibility. And that's what we like about Kubernetes. It allows us to do almost anything we want, including the things that many of us did not think were possible until recently. Over time, everybody hoped, we all hoped, at least we all in Kubernetes community, we hope that developers are going to adopt Kubernetes as well, that it will not be a tool, a platform reserved exclusively for, let's say, sysadmins or operators. And that did not really happen. Developers are not jumping into Kubernetes, and there is a good reason for it. And the reason is very simple. It is very complex. So we are left with a couple of choices to make, or at least in the past. One is to say, hey, actually, let me backtrack. Let me stop here for a second. I just realized that I'm saying something that is not correct. When I say developers in this context, I mean people working on end user applications. Everybody's a developer in a company today. Everybody writes code. So sysadmins are also writing code and testers are writing code. So when I say developer, I mean people on a very, very left side of the equation of the life cycle of applications. Anyways, so we have a couple of options. One is, hey, let's pause what we're doing for months or even years until everybody has enough understanding of how Kubernetes works. And when I say Kubernetes, I mean the whole ecosystem, because it's not really only Kubernetes. You need to figure out service meshes, you need to figure out ingresses, you need to figure out storage, you need to figure out a lot of things. And pausing everybody's work for months or even longer is not going to happen. It is unrealistic because developers in this context, they want to write code and they want that code to run in production. Now, the option number two that we have is to say, hey, we are not shifting things to the left. We will have developers writing code and we will have admins deploying that code to production. But that's something that we've been struggling for years to get away from, because we are shifting to the left. We are not shifting to the right, at least not in this context. most of the people are sick of opening Jira tickets saying, hey, can you deploy my new release? Hey, can you package my new release? Hey, can you do this? Hey, can you do that, right? We want to empower developers, and then we are running into problems. How can we empower everybody to do everything related with the life cycle of their applications if everything is extremely complex? So in the meantime, we figured out better ways potentially to package applications, let's say as Helm charts or customize something. But again, that's not shifting left for a simple reason, because Helm, if anything, is more complex, not less complex than using directly Kubernetes manifests. Writing a Helm chart is complicated. Writing templates for Helm charts can become a nightmare, and so on and so forth. So most of us ended up having admins or operators or whatever we call people, you typically on the right, doing all those things for people on the left. Okay, hey, I'm going to define the application for you. Hey, I'm going to set all the parameters. I'm going to say whether your application should use Istio or it should use, I don't know, Linkerd, whether it should scale horizontally or vertically or both, and so on and so forth. So we had people doing work and delivering those definitions to developers, which is, again, opposite of what we are trying to do. It is opposite from empowering people, because ultimately what we want as developers, or at least I hope, at least I want, is that, hey, I am in full control of my application, and that means that I'm writing code, I'm writing tests, I'm deploying that to that application to production, and so on and so forth. Me and my team in charge of an application is in charge of the full life cycle of that application. So we need additional layers on top of Kubernetes, something that will make Kubernetes as easy as, let's say, creating VMs in cloud is today, right? You don't need to understand how hypervisors work in order to go to Google Cloud or Azure or AWS or Alibaba or wherever you are today and say, hey, I want 3 VMs and I want them to be medium size. That's what we want with Kubernetes, right? We want to get to the point where somebody manages the complexity behind it, somebody makes the hard decisions, somebody who is dedicated to managing the system, and then everybody else can use it in a very simple way. Or if you're a bit older, if you did not just finish university, we need to get to the point with Kubernetes that the experience is very similar to what let's say we had with Heroku maybe 10 years ago or something like that, when it was all the rage, right? Now, the choices that we are having are very complicated for a simple reason, because of all that complexity. We need to choose, do we want to adopt a platform running on top of Kubernetes that is extremely opinionated, and that opinionation simplifies how everybody should operate their applications, how they should deploy and what's not? Or do we want to provide a platform on top of Kubernetes that will enable operators to define in advance certain parameters, certain guardrails, so that everybody on the left of them can just say, hey, here's my application, I want to run it. And I will tell you a couple of things about my application, like, hey, it is stateful or it is stateless, it should scale, it should not scale, some very easy questions, and say, go, 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 similar to Heroku, right? There are a couple of options. I'm not sure, depending on how much time I have, how many options I will be able to show you. And I will start with Shipa and show one potential solution of how we can enable operators to define what are the guardrails and have developers be able to deploy their application without much fuss. So let's switch to my screen. Here we are. Now, before I jump into Shipa and what's or not, I will show you probably the simplest Kubernetes definition I could find. And here it is. I put it in this directory. This is the simplest definition. It has a service, which absolutely every application needs to have. It has actually a couple of services because I might want to do canary deployments, and it has analysis template because everybody's auto-scaling their stuff today. And it has rollouts because, again, we need the canary deployments, and it has yet another service, and it has a gateway because this happens to use Istio, and it has a virtual service because that's a requirement for Istio, and so on and so forth. So if you look at a very simple example like this one, and on top of that include that we need to do some templating because pure YAML does not work, this is a pure madness, right? There is absolutely no way that more than a very small handful of people in average in a company will be able to define this. So the alternative would be something like this. And I will be starting from scratch here. I will go to, let me just find the screen. Here we are. I will go to a potential solution for that additional layer on top of Kubernetes, which in this case is called Shipa. And I will do my best to show you a couple of other examples that are not Shipa. And I will simulate that I'm an operator right now, right? I'm going to try to help developers deploy their application with extreme simplicity without losing the control themselves. So developers will still be in control of what they do, when they do, how they do, but with guardrails. And to do that, I will create a framework. A framework is a way to create the guardrails I was mentioning. It is the way to create constraints and certain choices that will simplify everything for people deploying applications later on. So I will put a name like my framework, right? It can be any name we want. And then I need to start making some choices. Hey, should this group, would it be better for them to use Traffic or Istio or something else? What is the namespace? Should this something be used by everybody in a company or only certain teams and so on and so forth? So I'll quickly go through the options here without really going into much detail because that would take a lot of time. Like, hey, I will give them unlimited memory in CPU and what's not. Typically, that would be a recipe for disaster, but we are going to go easy now. I'm going to make it public so that anybody can use it. I could also select which teams should be able to use this framework, but I will make it public. How many applications can be deployed? You always need some guardrails because it can to avoid going out of hand. But in this case, again, I will simplify it by saying any number of applications. With what are the registries that are allowed or not allowed, and what are the networks and application level policies. And those policies can be very simple or very complicated depending on how far somebody wants to go. Like you can select the rules, you can define new rules, and so on and so forth. A lot of stuff here that I could do to help other people make the right choices when the time comes to make right choices. I will disable those just for the sake of simplicity. So that I can go fast. And finally, everything should be scanned. I should enable scanning my applications for security vulnerabilities, scanning the whole platform. I can specify what should be ignored, what should not be ignored, all that jazz, right? Which again, I'm not going to specify because I want to cover as much ground as I can. Once I have the framework, all I have to do is add a cluster so that Shipa knows where is the cluster that needs to be managed. And to do that, I will, if you give me a second, I will do that right now because I want to show you everything from scratch. I have a cluster that I already created, but I did not add it to Shipa yet, and I will do it right now. So where is it? I have a helper command here, which I'm going to execute here. Okay, cool. So I will add a new cluster to Shipa itself. I will call it with a very creative name, my cluster. I will select that within that cluster, people should use the deploy applications based on the rules specified in the framework I created a minute ago. And I will need to tell the address and the token and the certificate so that it knows how to connect there. And to do that, I will copy it from my screen. Do not try to copy things from my screen because I promise that those credentials will be removed by the time I finish this session. So don't try to hack me or anything like that. Here we are, and certificate. And then I can tell Shipa, hey, this is the IP of the cluster, this is the load balancer, this is the ingress type, which could be load balancer or not port, depending on whether you're running on-prem or somewhere, the email, whether you want to debug stuff, just going through it very quickly. Okay, now that I told Shipa what are the limitations and what are the frameworks that somebody should be able to use, I'm finished as an operator. My job is done here. And I can say, hey, you guys just start using this, start deploying your applications. And to do that, I have one more step that I forgot to do. And that is that I will need to log into Shipa. Here we are. Okay, cool. Now, as a developer, from here on, everything should be extremely easy for me. But while I'm still in control, and that's important thing, it needs to be easy without losing control. So as a developer, I don't want others to tell me what I can and what I cannot do. Actually, I do want others to tell me what I can and cannot do. But once we establish those guardrails, once we establish what is my play field, where I can, what is the area within which I can move, I should have full freedom. And that full freedom is to create an application, for example. So I can say, hey, I want to create an application. I will call it like this. There we are. And I can say, hey, how about I deploy my application? App deploy. I want to deploy an application. What is the name of the application? DevOps Toolkit. And what is the image? I can deploy directly from source code, which is slightly slower, but has certain advantages. And in that case, if I'm deploying directly from source code, I would not need to specify anything else. This would be everything I need to do. I just need to tell it what is the name of the application and where is the source code. And it should figure out everything else. It should figure out which Kubernetes resources to define, where to run them, how to run them, all the jazz, right? But in this case, I will not deploy from the source code because I don't like that option personally. I will assume that I already built an image with my application, and I will just say, hey, deploy the application. Here's the image. This is the name of the application. That's all you need to know. That is all that I need to know, and it should just run it. And if I click the enter key, which I did, it should take a couple of seconds, 5 maybe more, and my application should be up and running. There we are. I mean, actually, we are not there yet, but we will be soon. And right now it is pulling image from wherever that image is stored. It is deciding what to do, like, hey, it should run one replica of the application. It could be more, depending on the parameters that I set in advance. It is deciding what will be the address of my application, what will be the resources of my application, doing all the heavy lifting, but I don't care about any of those things. What I care about is that I said, here's my application, run it, easy. Now, if I do Shipa app info and say, hey, give me the information about the application called DevOps Toolkit. Where is it? Come on. There we are, right? This is all the information we need. Hey, this is the ingress controller. This is the plan. This is the units. I could scale it up. I could scale it down. What's or not. Everything that is to be known about the application. But the thing that matters the most here in this context is the address. And the address, if I copy it and paste it in my browser, you can see that my application is running, right? And behind the scenes, what we got what we got behind the scenes is that it created everything it needs to create. So kubectl get namespaces. It created a namespace for me. Here it is, kubectl-n, this namespace get all, and ingresses. It created all the resources for me. It is making sure that everything is running. And all I really did was say, hey, here's my application, run it. Now that's one option that we can approach. Take a platform, use that platform if it fits our needs. In this case, it would be Shipa, and just give it to people to run, create the guardrails, and what's not. The alternative to that could be instead of using already created platform, would be to build our own platforms. And if we would build our own platforms, then we would need to make choices. Hey, how should our platform be built? What would be the components? What can we reuse from the community to build such a platform? And the answer to that, most likely today, is open application model. Open application model is an attempt to define an interface that allows us to define applications instead of defining resources. And that is a huge differentiator, I think. And what that means is that when you deal with Kubernetes resources, you're not defining applications. This is a very important thing to understand. Kubernetes resources are not definitions of applications. They're closer to being definitions of infrastructure needed for applications, networking, ingresses, storage, this and that, right? Kubernetes is more focused on infrastructure and defining resources than defining what applications are. If you take open application model, which again, this is now a completely separate subject, just alternative to Shipa, we can do something like this. Hey, this is the definition of my application. Anybody should be able to define this because it's very simple. It says, hey, I want to have an application and I want that application to have some components. And that component will be web service. It could be something else. It could be anything. And if I have time, I will show you what that anything is. And I will define a couple of properties for that application. This is the image. This is the port. And I want it to be exposed through ingress. And then that same, what you're seeing on screen, those 15 lines of YAML is equivalent to probably something around 100, 200 lines of pure Kubernetes definitions, right? It is reducing, it is removing all the clutter, it is about removing the definition of resources and focusing on what application needs and only about what application needs. And we can do something like this: kubectl apply -- file name dt simple.yaml, and the application is running. And again, the end result is very similar to what I showed you with Shipa. Behind the scenes, all the different resources, everything should be defined, and I should be able to see my application running right now. Here is the same application defined in a different way using open application model. And the way how that happened is because somebody has to create a relationship between what are the Kubernetes resources and what is the definition of an application. So definition easy. This is easy for everybody because it is reduced to only the things that are really needed for that specific application. But then somebody needs to make a relation between that and Kubernetes. And that relation can look something like this. For example, which is now this is mindfuck. This is crazy, and no developer is likely to ever understand this. But this is a way how an operator can define a component definition and can say, hey, if somebody wants to deploy a front end, those are the things that will be created behind the scenes. Those are the parameters. This is all the magic. Or for example, if you look at traits, similar thing. if somebody wants to use autoscaler in their front end, this is how it should be translated to Kubernetes. But when the time comes to use all that stuff, those and few other examples can be as easy as this. Developers saying, hey, I have an application called like this. It consists of two components, front-end and back-end. The front-end, for example, will have auto-scaling, will have ingress, and there is nothing else I need to do. And once you establish that relation between defining what your application can be and how that translates to Kubernetes, you get the combination of both worlds. You get the power and extensibility of Kubernetes that anything available in Kubernetes ecosystem is at your reach, but you need to know what you're doing. But by knowing what you're doing, you can define those application models that then simplify all those hard choices without losing control, while still giving control to developers. Hey, you can do anything you want within those limits. And anything you want is just go ahead, define application in the format that fits your needs, and you will be forced to create only the things that matter. Like, hey, this is the image. If you don't specify a trait, then nothing happens. If you want autoscaler, you just need to say, yes, I want it. You do not need to define 175 lines of YAML just to get autoscaler, because the relation between components and traits on one hand, created by admins, and what application can do is established. And I think that I'm just around the time now of my 30-minute talk, and now we have 15 minutes for questions, if I'm not mistaken.
Is correct. Thank you, Victor. I always like that your presentation is always hands-on and you like do the demo right live. I love this always.
Otherwise, you're faking it, right?
Exactly.
You do it live.
Exactly. I like when you hit enter, like in just 5 seconds, take a sip of water, and all right. But it worked. And actually, I like this kind of tooling. As you know, like Victor and I have worked together, I do have a team called Developer Experience, which our job is to do exactly kind of things that Shipa is doing, make the lives of developers better through like tools like this. We got a couple of questions here. The first one being, if you're launching a V1 of a service, do you recommend Shipa? Or would it make more sense if you roll it out maybe after you have a couple of customers? Like when do you introduce this kind of thing?
It really depends on, I cannot give an answer that fits all to such a broad question, right? It really depends on your experience and how far you are in Kubernetes journey and what's or not. What I do, however, recommend always is try it out. And when I say try it out, I don't mean only Shipa. See what fits. But I would not like myself if I would give you the answer without having more detail.
Correct.
Then you can send me to court later.
I don't think there will be like a court case like Kubernetes was deployed too early. That's funny. But you're right. I think what matters is shipping that thing, right? That service. And if it feels right using something like Shipa and you're able to manage it, kudos. If not, like do what works, right? And make sure that you are able to, have your customers use your product. Yeah.
If I may just add one more thing, I just remembered as answer to the question. What is extremely important is that you do not go crazy. And that means that if you're starting in Kubernetes, do not even think about service mesh, for example. And I'm using that always as an example, right? Yeah. You need to take it step by step. Otherwise, if you come to a conference like Craft and see all the good things that you can imagine, you're going to fail miserably if you start implementing them all at the same time.
Yes, the conference effect, right? You go back into your office and now you're implementing Shipa, refactoring all your code, and suddenly all the tests, I'm changing it to Cypress. So yes.
Exactly.
Don't do that. See what fits, apply things, Cool. We have another question. How do developers know what's available for them? example, what traits are possible in the example you have shown?
Yeah, so traits, so those were two examples, right? Shipa and something completely unrelated with Shipa. I'm trying to be always not biased. So if you're talking about traits, how you know what is possible, I think it's one of the missing links. Now, you can definitely see how something is possible. I'm not sharing the screen anymore, but doesn't matter. You can just query the resources in Kubernetes because all the traits and components are Kubernetes custom resources. That's one of the things we like about Kubernetes. Everything is there. You can query everything. You can find out. Now, that being said, if you know how to query those things, if you know how to find out those things in a Kubernetes-friendly way, then you're probably not going to need Open Application Model or SHIP or any of those things because you're already an expert. Exactly. And I hope that communities behind the Open Application Model will adopt, and kind of that's one of my suggestions, will adopt some kind of dynamic discovery from the CLI so that you can say, hey, what are all the components in a friendly way? Something like get components without really going through Kubernetes resources. But that is not solved now. Whomever created those components and traits for you to use would need to create some kind of wiki page to document it for you.
Yeah, and I think that always helpful anyways.
And for a day, and then it becomes obsolete and
outdated.
inaccurate.
Exactly, yeah.
Outdated, yes.
Yeah, totally. So actually, there's a follow-up question, I think, related to that, which is, don't such abstractions mean that developers need to learn the abstractions in addition to Kubernetes? At least if something doesn't work, they need to understand what's going on under the hood.
Yes, so that is a constant struggle, right? We are always building abstractions on top of abstractions. And it's very hard to find that balance. Yes, if something goes wrong, and if that same developer is in charge of debugging how that's something wrong, how to trying to debug what's going wrong, you have two options. Either they have a service of kind that will help them do that, or they go bazooka and do it directly in Kubernetes, right? So, and which would defy the purpose of simplification in the first place. The same way as, hey, if something goes wrong with hypervisors, with your virtual machines, what do? Most people do not know about hypervisors when they use AWS because AWS provides services for them that allows them to debug the issues without really going into such detail like, hey, how hypervisor works, right? I bet that majority of people using AWS do not know how hypervisor works, and still they're able to debug their issues and figure out what's going on. So that would mean creating some dashboards, let's say in Grafana, maybe something like a Backstage from Netflix that will unify all that, right? So at the end of the day, I see two major groups of engineers working in a company. Either you are developing something for the end user, so let's say application developer, or you're providing services to those developers.
Correct.
You're not responding to Jira tickets, to clarify, just as AWS is never going to answer your issue, hey, can you create a VM for me? You're building tools so that others can consume and so that other people's lives are easier and they can focus more on their work.
Totally. I think for me, the way I describe it is like these are like experienced teams and then platform teams, right? And then they have different roles in the organization. And in that sense, those platform teams create these abstractions, right? Try to make the lives of the experienced teams, easier, and it's essentially faster, right? They don't have to, like you said, I like this kind of comparison to like hypervisors, right? Like I don't know, and that's okay. I mean, I don't need to know all the details there. But I know that I could, actually get EC2 instances and make that work.
Correct. Everybody has a customer, and your customer is either the end user or other devs in a company.
Exactly. Now we have another question. I guess does Shipa support some kind of application database migration strategies if we are not backwards compatible, i.e. need a short downtime?
Yeah, database migration, no. Shipa as a product right now, it is focused on, let's say, first-party applications. I'm not sure whether that's the term. Whatever is not a third party, right? So it doesn't really deal with databases. It deals only with your applications. It assumes that everything else is managed in any other way. And since it is running on top of Kubernetes, it is not really removing any of the other options you have. It is just simplifying part of your life cycle, let's say. And that part would be your own applications, not databases.
Got it. Yeah, and it makes sense. I mean, that's even a harder problem to solve for, right? Database migrations under Kubernetes is still kind of a iffy problem.
Oh yeah.
Now another question around is how does Shipa plug into your CI/CD infrastructure? Where will you put something like Shipa?
So it depends on what we're doing with CI/CD. So if by CI/CD, everybody by CI/CD means some kind of pipelines.
Yeah.
So if it has a CLI. Everything has a CLI today. Everything has an API. So your pipelines would be just ship up deploy, right? Now, if we switch into right now, Shipa is very CLI focused. That will change in the future, but today it's CLI focused. If you would like something more like GitOps like, meaning that you define it as code instead of executing it as a CLI, then you would need to wait for a bit until Shipa gets that, or go for open application model that I showed you earlier.
Got it. And actually, on that point, the things that you define in Shipa, is there a way to export them to be more like another type of definition of Kubernetes?
Yes and no. And again, the answer is right now, today, at this very moment. The frameworks that I did before and clusters, you can export that to YAML, and you can manage it through YAML as well. The applications themselves, today, right now, it is manageable only through the CLI. I know that the team is working on making that through YAML as well. But right now, it's only CLI for the applications, while everything else is definable as YAML or exportable as well.
Got it. So that means that you will be working with more like open type definitions in the future, or? Yes,
that's pending decisions. It's not 100% defined yet. Yeah. How will the future look like? But yes, that's the direction.
Cool. And there was like one last question here around. So if we now, it kind of similar to before. So we abstracted our cloud infrastructure. Now we're abstracting our orchestration of deployment of infrastructure. So what is the next level of abstraction? Like what is next?
I don't know yet. I don't think that I think that we, and when I say we, I don't mean Shipa, I don't mean I mean industry.
Yeah.
We are still trying to figure out what will be that abstraction on top of Kubernetes. And it's very hard to predict what is the abstraction on top of abstraction that you did not figure out yet. But it will be some form of, what I'm completely certain is that it will, whatever it is going in a direction that sometime in the future, most of people will not know that there is Kubernetes below that something. Kubernetes will become implementation detail completely relevant for majority of people. And you can see that, for example, if you take a look at Knative or Google Cloud Run, right? And go through Google Cloud Run documentation, you will hardly see the word Kubernetes anywhere.
Yeah.
Now I can guarantee you that Google Cloud Run is powered by Kubernetes. There is Kubernetes below all that, but it is becoming irrelevant. So yeah. I cannot say what comes afterwards, but for now, I think that we are all focused on how to make Kubernetes irrelevant. Not irrelevant, very relevant, but
necessary, but not in top of mind, right? Like you'll know exactly. That it's empowering things, but it's not something I need to know like from like at the console level. Yeah.
Just like hypervisors, going back to my previous example.
Yeah.
It's completely relevant. I have no idea if you ask me, what is the hypervisor Google is using? I have no idea, and I don't want to know.
Exactly. That's a total good thing. Yes. Well, thank you so much, Victor. We're going to be sending you a little keepsake with your little mug there inside of a mug.
Oh my! I love it.
Yeah. So it's always fun to have these conversations with you, Victor. And again, if you haven't checked out his YouTube channel, do it. He publishes a lot of videos. I find them entertaining and insightful. So thank you for putting those up. I think I'm flooding my teams with your videos too much.
Thank you.
But keep up the good work. Thank you for sharing, Shipa and also a version of non-Shipa, so we can really balance things out. So.